right, hi everybody, welcome. So this is the Calling All Systems webinar here for this month, here May 2023. I'm Barclay Brown, I'm the INCOSE CIO and your host for this session. And one of the first things I want to do is acknowledge the team that put this together. So Honor Lind, who's on the call here, is INCOSE Director of Marketing and Communications. She's really the one who thought this all up and got this all produced and so forth. And she's joined by some of her team from the UK, Dot the I, Joe Corbett, and Emma Jane Taylor is here to support us as we go along here. So let me start by introducing our panelists here, and then we'll get right into the content. So Dr. Charles Krueger, who goes by Charlie among his friends, and I guess we're all your friends now today, right? If that's all right. Okay. He's the founder and CEO of BigLever Software, who's also BigLever is also the sponsor for this particular session. I should also mention, by the way, that Dassault is the sponsor for the whole series of these Calling All Systems sessions, right? BigLever is the sponsor for this particular one as well. So Charlie's president, founder and CEO of BigLever Software, and also past co-chair of the INCOSE PLE working group and editor for feature-based PLE standards in the INCOSE Standards Development Department, and as a liaison for the ISO methods, ISO, what's it called? Sorry, look at that. ISO Tools and Methods Working Group. So quite involved in the industry. He's kind of, I think it might be fair to say, I've worked with Charlie for years, so I can take some liberties from my own knowledge. He's kind of made this product line engineering thing his life's work, right? At least in recent years, right? And so we're delighted to have him here to talk about this. Next, Marco Forlingieri is a senior technical representative with IBM Engineering for Southeast Asia, and he's also co-chair of the INCOSE Product Line Engineering Working Group. So he's here and also an assistant director for the Asia and Oceania sector in INCOSE. So very involved in INCOSE and PLE. Dr. Bobbi Young up next here is a retired Raytheon Technologies Engineering Fellow and a certified architect, and now is an adjunct professor at Worcester Polytechnic Institute, teaching MBSE and feature-based product line engineering as well. She's a co-author of a book on object-oriented analysis and design, contributor to the Open Group SOA book, and was actually active duty Air Force officer and commander in the Naval Reserves. I didn't know that part of your background. That's pretty cool. Okay, all right, I didn't know that part. Bobbi and I have also worked together for years, right? Rowland Darbin is INCOSE PLE Working Group co-chair, and he's Product Line Engineering Center of Excellence lead at General Dynamics Mission Systems, in fact, that product line or that business unit lead for PLE. So real experience from in the trenches. Brian Pepper, finally, is Industry Business Senior Consultant for CATIA Magic. This is part of Dassault Systems. His focus is on techniques for MBSE and complex systems, both using UML, using SysML, in the defense and automotive industries. He's a Six Sigma Black Belt, DODAF certified, and OMG certified systems modeling professional, which is a SysML related certification. And Brian was also telling me he's headed up a lot of PLE type of work for various clients through his work in Dassault. So that's the panel. That couldn't have a better panel for this subject. So let me just jump kind of right in the middle of it and try to figure out what this PLE thing is, right? And if I think about it, it's very natural for engineers, once they've created a system or a product or something, to say, you know, we need another system or product sort of like this, but a little different for a different customer, for a different market, for a different use for the next year or something like that. And so the most natural thing to do, and we've all done this, right, is to copy all the specs, all the designs, all the material, all the software, whatever, and make a copy of it, and then start modifying it to make the product, the next product. But that's kind of an obvious approach, but it might not be the best approach to kind of reusing past material. So let me just throw it to the panelists at this point. If that's a kind of a traditional approach, some have called this, I don't know who originated this term, Charlie, was it you or someone else, have called it clone and own, right? You clone all the information you've got, but then you own it, right? So what are some of the disadvantages of the approach? Why do we even need to talk beyond that? Are there disadvantages to that approach? We'd like to start. Go ahead.
Yeah, the main challenge is going to be, you know, as you get more and more of these copies created, and now you have to maintain the entire portfolio, right? So what if there's a defect you find in one of your products, but you got 10 copies? Well, who else has that? There's no formal way of managing that using the clone and own approach. So now you have to put on your tennis shoes, run up and down the hallway, find Bob, because Bob knows, you know, that subject matter expertise. And so it's a very air-prone, labor-intensive activity. So what we need to do is formalize it and get much better at engineering it rather than relying on the tribal knowledge, subject matter expertise, dependence on individuals.
So others on the panel, what have you seen effects? Do you see this happening, by the way, or am I just, crazy? Is nobody does this anymore?
No.
So yeah, I mean, from industry's perspective, this happens all the time, right? I mean, programs get started up and they're almost always a derivative of prior work or building on something that was done before for an adjacent customer, or some reason why somebody else comes and said, I want what you have, but I want it just a little bit different. And every one of those differences drives a justification for either a clone and own or some sort of ownership or divergence. And really the trick for PLE is how do we manage all that divergence by encapsulating the justification for legitimate change, but not allowing that to diverge the baseline. We wrap it in what we call a feature, and then that becomes something that we actively manage as an organization, and it allows that sharing of knowledge like Charlie was talking about without having to duplicate and clone and own and put that knowledge in people's heads.
Okay, very good. Comments from anyone else on the panel about that? I like the distinction. Marco, go ahead.
No, they were quite clear, so I will subscribe exactly what they said. Maybe just one thing from personal experience, I was used to call it also reuse by accident. Because so you are in a new program, as you said, a new project, and then you remember that, oh, but I did something similar. Oh, there were similar requirements, so I had a similar specification. Maybe I can start from there. The main problem is that that project was not intended to be built for that customer, right? So that's where the problem starts. Maybe you can reuse the requirements, but then in terms of some of the requirements, but the performance are different. So the function, some of the function are different. The architecture are different. The constraints are different. So at the end of the day, you want to save time, but you will end up in wasting more time. No, that's the bigger risk, I guess.
So you mentioned, Marco, an important term there, reuse. I mean, that's kind of the original goal, that you might think, well, of course, we want to reuse things. We don't want to reinvent everything from scratch all the time. So reuse is kind of this goal, but the clone and own approach may not be the best way to achieve reuse, right? So before we go on to what might be some better approaches, let me throw this one out too. Is there ever a time when that approach, that clone and own copy kind of approach, is appropriate, that we would want to do that, or that would be the right approach, or maybe never? What do you think?
I would say that, so clone and own. So let's say if it's not managed, it's always bad, right? So it's always a copy. You cannot manage a copy. So you have like a baseline, or the original artifact, the original asset, and then you're making a copy out of it. So the moment you make a copy, it's another thing. So it has its own life cycle, its own versioning, and so on. So you can do clone and own, but it needs to be managed clone and own. So you need to at least to keep a traceability between the baseline and let's say the clone, right? Now, is it a good practice? When you have to make really small changes, when there is not a complex product, you know exactly what you are going to change, it probably can be done. But for me, it must be always managed clone and own, not just copy paste, right? I don't know, what do the other things about it?
Yeah,
So go ahead.
I'll do a quick cover here. So if you're making copies, but you're maintaining all of them in parallel, that's the problem, right? Trying to sustain multiple, almost identical things. If, very small number of cases where you can justify clone and own as the most efficient approach. But if I have a thing and it never changes, it's been released, nobody will ever maintain it, nobody will fix a bug, nobody will create a new version of it. I don't care. I can take a copy of that if it's, meets my needs. I get 100% reuse on day one. I don't end up with two things I have to maintain because one is immutable. That's a very, very rare scenario, but in all other cases, it's going to eat your lunch maintaining multiple nearly identical things.
It's a really interesting point, Charlie, and then we'll go to Brian for a comment as well. And Andrew Poisson in the chat here mentions, can you clone and own and then manage the clone if you don't need to maintain traceability? And that's kind of the key, Charlie. And it reminds me of some other things like a pure waterfall process, which works wonderfully if there's never any change as you go through. So these methods that rely on there never being any change in something are probably wildly optimistic, you know, because things always do seem to change, right? So that is kind of the reality. Brian, what do you think?
Yeah, just some of my experience with the clone and own is I've seen it work fairly well with, you know, where you actually clone a model like template. So where you have your logical or your conceptual model, logical architecture, your physical architecture, all like defined in a structure with pre-built, you know, tables, and then you copy that and then you can build a feature from that, right? Start doing feature models from that. That means then everybody has like a consistency in the structure. But again, it's like you clone it and then you literally own it, right? Now you have to start working on that and you don't go back. So I think that's.
So it's these disadvantages, great point. And you mentioned another magic word we'll be dealing with quite a bit here, features. But so it's these difficulties in clone and own that gave rise to this whole concept of product line engineering, right, as a term. And you could think of product line engineering as just, well, we have a product, we have products, we have product lines, and we do engineering. So aren't we doing product line engineering? You know, we just as simple as that. Well, maybe not. Product line engineering is really about the solution or possible solutions to this problem we've identified here. That just copying isn't the best way. So maybe let's kick this around a little bit. What, you know, the term product line engineering, are there different approaches to it? Is it just one thing? Does everybody understand this term? What have you guys seen in the world about that?
So I can speak up here on that one.
Sure.
I've seen many different ways of how to do product line engineering, having these very intense configuration management type of ways to do product line engineering, to even if you have a particular business area, even within that same business area, you're going to see a lot of different ways that people have used clone and own or reuse, whatever you want to call it, to do product line engineering. And the big thing that they're missing is there's a lot of commonality that you can find even within a business unit, as well as across the different business units or mission areas, whatever you want to call them, that you're not taking advantage of by, you know, kind of putting those blinders on and saying, okay, this is my particular business area or mission area, so I'm only going to care about that particular aspect. Or like what we'll do is we will share. So a lot of the clone and own isn't so much just within, you know, a same set of type of products, but they clone and own from one product to another. And that's where it really starts getting different, and you can't bring them back together anymore. So it's more like a starting point. And then, you know, because you have different people, different architects, chief engineers, and all that, managing them, they want it done the way they are used to seeing things done. So they'll change things around, even though it's very much the same from one product to another. They'll just change sort of where they define their boundaries of different subsystems. They'll change the name, and yet it's exactly the same thing. So I've seen a lot of those kinds of issues, as opposed to with a product line approach, and I'll call out the feature-based product line approach. It helps to focus on that feature, where then you can look across all the different needs and understand where you can make things common, you know, and take advantage of that commonality. And then still, you know, there's going to be variability. You can't make anything really 100% reusable forever. So you might as well admit that up front and understand and make those good cost benefit decisions on where that variability is, and then manage that.
So it sounds like maybe the only thing worse than clone and own would be not copying at all, because it's certainly even more wasteful to re-engineer the new thing from scratch. and not even like that would be worse, right? All the effort to re-engineer the whole thing from scratch versus clone and own. Now we're going to get beyond that. So you mentioned, a couple of people have mentioned features. So let me just kind of introduce the topic this way. I think of it as if I go to a car maker's website and it says, configure your new F-150 or whatever, right? And I look in there and it says, all right, do you want the sport model or the luxury model? And as I pick the sport model, it says, okay, now do you want these kind of wheels or those kind of wheels? Because these kind of wheels are only available in the sport model. These other kind of wheels, they're only available in the luxury model. You can't get this with that. And as I work my way through this kind of network of features, I make selections, right? And that's kind of how I intuitively think of that. So is that a good notion for what we mean by a feature, or somebody explain about that? How do you see features in your environment?
Yeah, so that's a common analogy I always make, and I have nothing to do with automotive, but I do see there's a question in the automotive section. I'm sure somebody on this panel can talk to you directly. The notion of a feature is often something that gets a little confused, especially when you talk about agile features, which are more about what capabilities we're going to go implement. From PLE perspective, if it's something that everybody uses, it's a capability of the system. If it's something that drives differences across your family of systems, then we define it as a feature so that we can encapsulate that knowledge about why that difference is justified for one customer versus another. So there's a specific definition of feature in feature-based PLE, which I think is really the enabler to having these conversations and driving away from other forms of managing this kind of divergence people use. Like we'll often hear versions of things, or things that allude to a baseline instead of we're sorting all of these variants simultaneously, right? So this one has these features, this one doesn't, or flavor of features.
Right, and there's a tie-in between why do we need features for product line engineering? So according to the ISO standard, a feature is just a distinguishing characteristic, right? So in product line engineering, feature has a special meaning that's different from the 37 other ways feature is used in engineering. It's just the thing that makes one member of a family different from another. And so that's that intuitive sort of, oh yeah, I can choose, make these choices about, do I want the sport package or not? So that's a distinguishing characteristic. It's a feature. Now, if we can manage that, what it allows us to do that's slightly different from reuse and clone and own, instead of having multiple copies of things, we can have one shared copy that everything is derived from. That's going to be the key. Let's not have clone and own copies that we need for every product. Let's have one consolidated set of content, and then the features can say, well, if I have this feature on a product, then here's the requirements I need and the ones I don't need, and here's the source code I need, and here's the source code I don't need because I don't have particular features. So it's this idea that reuse in the traditional sense, it's a copy event. It happens once, and it's a wonderful thing on the first day, and it's a terrible thing every day after that. Whereas the sharing is more of a journey. We're all going to join together. We're going to work on the family by creating one consolidated set of content, and now formally manage the differences using this abstract notion of a feature that will help us derive individual products from the shared content.
So that's
maybe
great. Yeah, go ahead, Marco.
Sorry, now to comment what just Charlie said, the main difference with let's say the automotive example that you mentioned is that at the end of the day, the user is configuring the car, right? And he gets the physical product out of that. So product line engineering goes beyond that, because it's a practice also for the engineers themselves to, as Charlie said, to choose to take the features and know that this feature is linked to the requirement, to the test case, to the 3D artifact, and to the system model and so on. So this is the difference, no? And then there is another aspect. For each artifact, as also Charlie was mentioning, there is the configuration of the artifact itself. So you need to manage the versioning, the configuration of the artifact. So that's why it's more than just configuring the car. It's a good way to start understanding the concept, for sure, but then it goes beyond that. And then the second point that I wanted to add is why do we need the features? Because the standard said that, okay, this is an easy answer, right? But what for those that don't like standards? No, they go again. There are people like this, I don't care about the standards, fine. So there is a logical understanding of that. And the following for me is that if you build the variability in your mechanical system, so your mechanical design, if you build your variability just in your software source code, or your system model, there will be people in the organization that don't understand the system model. People in the organization don't understand the mechanical design or the electrical schematics. So you need to have an independent model that we call feature model that's independent from the other assets, and that everybody can look at it and just with few notion of notation, understand what it's about. And that's what a feature model is. Everybody, even a child, can understand a feature model, right? So that's the main advantage, the biggest advantage, I would say.
All right, terrific. So a couple of things from some of the participants that are chiming in here, which is really interesting. So I guess let me kind of summarize some things here and be a little bit of a devil's advocate perhaps here. Feature-based product line engineering, or any kind of product line engineering, if there were other ways, has got to cost something, right? So you have this, the clone and own kind of process, which looks easy and quick and very cheap, right? We just copy, right? That's very simple, right? Very quick. So it looks cheap, right? But it has costs over the long term, as Charlie was pointing out, right? But setting up the infrastructure or whatever is necessary to do this feature-based management, that has a cost too. So how do you justify that, and how do you show that it's useful to make that investment?
There have been some, I'll call them informal studies, right? So people that do the feature-based approach, and they're having to measure, time, and they're in their company. It's important to measure where value is invested. So what we typically hear is that the cost of creating and running what's called a PLE factory, with feature models and variations and shared content, it's about 10% of the cost of building and maintaining a single product. So think of your investment as 10% of, a single product engineering overhead. The return on that is typically about 200, 300%. You will triple or quadruple, double the output of your engineering team. So it seems like a lot. It's like, oh my gosh, we're going to have to, what's a feature model? We're going to have to figure out what that means. And, so there is an investment, but the return of getting away from clone and own tends to really quickly overwhelm that investment. But it's true, and it's oftentimes the barrier. People are so busy doing their engineering and resistant to change that they will say, I don't want to invest that additional time and cost and effort.
Yeah, I'll add in, modeling for modeling's sake is never adding value, right? And it's true for PLE. Typically, when I work with groups, they're already dealing with the cost of clone and own or duplication or these multiple baselines and merging. And we have funny names, like the ballooning backlog or merge madness, that kind of stuff. But really, you got to find that first step. And it doesn't have to be everything all at once. You just need to find the part where you can converge a baseline or you can stop a divergence from happening. And it provides instant value. I mean, it's like, when is it worth using a coupon at the grocery store, right? I mean, it's going to give you the money right now. Do it right now. You don't have to do everything. You just need to do the thing that's going to matter, right? And then let that thing be the thing that grows and turns into the rest of it.
Yeah, I noticed Andrew Muxon here commenting in the chat that the complexity in at least one situation that they had drove them back to clone and own, that somehow they concluded it wasn't worth it. Have you seen situations, to anybody on the panel, have you seen situations like that? And what do you suggest?
But the problem is, that sometimes, so it's always also organizational, right? So the organization is made to do product line. It's not because the organization is not ready or is not prepared. so probably will fail, right? So a simple example, there's a program manager, okay? So I was working for Airbus before, right? So the program manager needs to develop the next generation of aircraft and next product family, but then it just want to develop what is in the product, in this specific product, in the program. It doesn't want to develop additional things because it will sell that product. It doesn't care that maybe another program can benefit out of that later, because the program manager or the project manager is measured on that program, okay? So maybe for sure, it's important also to give budget to the program manager according to how much he can reuse, how much he can reuse across different programs, for example. And this is one big aspect, because if I'm not motivated to do it from a business perspective, since I'm measured against my program, then I will not do it. So this is also one very business reason why sometimes it's not working, why people refuse to do it. Okay, so that's what I saw on my skin, working on different organizations.
So this is a really important point, and it's especially a difference, it seems, with things like defense companies, right? Where you're building a program that's completely sort of isolated, like we're building this system, and then another defense customer, maybe a different agency within the same, defense organization, wants a similar system. Who's bearing the cost of the product line engineering, or who's getting the benefit of it? It's the contracting mechanisms are seeming to fund them independently. Like you build this one, and then you build this one. And so it's what you're pointing to, Marco, that could be an organizational incentive to re-engineer it, to start over, because that's the way the contract is written. Now, other panelists, what's your thoughts on this? Have you seen this situation?
Yeah, I've seen this situation too, where people thought, oh, it's just easier, especially because when you start combining the different programs together, they may have different security or IP data sharing type issues. So that's something that you have to be aware of and think about when you're building out your product line, so that you can build in a way of using variation and features and things like that to identify where you have certain IP or certain restrictions. They may be, based upon foreign sales or things like that, and build that into the product line approach.
I think Rowland's organization has this wonderful example. Like you're saying, it's always, if my perspective is, I put on my blinders, I'm just looking at a single program, and you tell me, oh, go join a product line effort. And if I look at that, well, that's more work. Why would I do that? From a single program perspective, there's no value. But if you step up to the broader level, and I'll let Rowland sort of speak to this one, but one of his, big contracts there, they said, we see the value of doing a product line, and the actual acquisition process, was done as a product line rather than individual program by program. And Rowland can speak to the enormous benefit to the government there.
Yeah. Charlie's referring to a highly published product line that I support, which is the live training product line under PO Stry. And, they have shown almost $1 billion in cost avoidance in PDSS and new starts and work over the course of the history of LT2. It's predominantly because we run from a single baseline. And when, one of these 22 programs contributes a fix or an enhancement or a new capability or whatever, the other ones get to absorb that for almost zero cost. And so it's really enabled a proliferation of capabilities that would otherwise not be present in any given product, right? And not only that, it's allowed programs to exist and survive through budget cuts that, because the entire product line evolves. Even if one of them has to step at one product, steps away, or a new one comes in, they can start from that existing capability right from the get-go. So it's been hugely popular. It's also changed the way that they've done the acquisition. So now they can just contract capabilities that get inserted into all the products instead of having to fund each individual program, which has been a huge enabler.
Great. So let's shift a little bit here. So we're getting a number of questions from participants and stuff. This is the next natural place to go is, how do you do this? How do we do this stuff, right? And rather than retracing all the ways that it may have been done in the past, let's kind of leap to the present and the future and say, what do we now? What have we learned? And what is the best way to approach this now? And I know a number of you will have comments on this. And especially, how does it relate to some of the latest standards? Some people asked about what's a feature model and how does that come in? And then also even how is there synergy with MBSE? Is that part of the current best approach and so forth? So a little bit of a wide open question, but what would you say to somebody who wants to get started in this? How do you what's the best way to do it?
I think we did two things, as this, I'll call it modern product line engineering approach was sort of being developed and early adopters were coming in. There was so much confusion in the industry, and everybody would say, "No, I know what PLE is," and there were again 37 different definitions, most of them unproven, and so it was a real problem getting adoption and momentum. So we did two things. One is we set up this PLE working group, the product line engineering working group in INCOSE. That became a place to sort of get the people together and try to agree on what is the right set of concepts, the approach and whatnot. That turned into the ISO standard effort, and so INCOSE facilitated my participation in the ISO working group. And so it took 4 or 5 years to get that developed, but with INCOSE and ISO and the community working together, and being very, very focused and fighting really hard to keep it clean and clear, we got, I think, a really wonderful standard. It's called the ISO 26580 standard on, feature-based product line engineering for systems and software. That's a great place to start. Go to the INCOSE working group. There's a primer that anybody can get for free to download, and then look at the ISO standard. And again, it's done, I think, really well, really clear. Some of these standards can get overbearing and confusing and not so clear. I think this one came out pretty well. So those are great places to start.
I'll volunteer another option, which is get a partner, because I know that when we started, this isn't expertise that people inherently have, and it's not nearly as mature through industry and publications as other practices in systems engineering. So, there's going to be updates to the INCOSE handbook coming out in the next edition, which is going to have a lot of information about families of systems, which is going to be extremely helpful. The new SysML v2 is coming out, and it's got feature-based additions built directly into it, which is going to be a huge enabler. But really, you need to find somebody who's done this before and get them to help you understand and see where the cloning and owning, where is the pain in the organization, and that first step taken needs to be to solve that problem, right? Because if you can't, just like anything, right? If you can't show demonstrable value right away, then the cost of the ideological viewpoint is going to overcome any progress. So that's my advice.
So a couple of people have mentioned. I'm sorry. Go ahead.
Please, no, please,
yeah,
please.
Marco.
Please.
So a couple of people have mentioned feature models, and most systems engineers are familiar with models of various kinds, functional models, system models, in SysML or something like this, right? What's a feature model? So let me give us a kind of a sense of what a feature model is, what it looks like.
So I leave the other answer because I want to talk about MBSE. So that's why I leave the stage.
Sure, go ahead. Yeah.
Bobbi, you want to take that, or I can?
Yeah, so the feature model is very much, it's a hierarchical, think of it as a hierarchical decision tree. So as you go down through your hierarchical tree, you're making various decisions on explaining what that feature is and breaking it down into the different feature options that apply to those features. Features are very abstract kinds of things because you're going to apply them across multiple different assets that you're creating, whether they're requirements or code or models or whatever. So you want them to be at these abstract distinguishing characteristics. But it very much is just as simple as a hierarchical decision tree.
And I'm picturing this sort of, back to my car configuration website example, right? That part of that tree might be visible even to the user because they know whether they're thinking sport package or luxury package. But then as you get down into the layers, some of that won't be visible to the user at all because the user won't know if you got the cruise control unit from this vendor or that vendor. And that might be a variation point that's way down there and invisible to the user, right? But it's the same, conceptually, it's the same thing.
Right,
Yeah.
right.
Yeah, sort of
And
like
Bobbi, I'd love to hear. So I was going to say, Bobbi, you're one of the people who I think probably knows more about using PLE and MBSE together than anybody else I know. And a lot of what we're talking about here has a lot of overlap. I'd love to hear your perspective on how those things click together and how they benefit her.
Yeah, well, a lot of people will say, well, why can't I just do my feature models in Cameo or Rhapsody or whatever their modeling tool, their MBSE modeling tool is? But that then comes to more of a tooling issue because, they can build hierarchical trees. You can model it that way. But again, the features are used across multiple disciplines. And if you're stuck in one tool, it's not going to be seen or used as information in some of the other tools. So this is kind of where the more digital engineering and having your set of tools being able to interact with each other kind of comes into play. I've seen a lot of people try to do a lot of different things within MBSE with trying to identify where the variations are. And all of it is I found to be very clunky. And they finally give up and then they call me in so I can show them a better way to do it. But yeah, if you have something very simple with not a lot of variation, then yeah, go ahead and do it in the modeling tool. But chances are it's not going to stay that way. And one of the big things that I really find is valuable is that if you're doing, well, I shouldn't say if, I think everybody should be doing MBSE. But when you're doing MBSE, why are you doing that, right? You're trying to help capture information, build up a knowledge base about the design that you're building. And so you're making a lot of these different design decisions and you want to kind of see how that you're using the modeling to kind of analyze out your requirements, your decisions that you're making, through doing some of the different diagrams. But it's basically a database of information and knowledge that you're capturing. And so part of that knowledge is what are those variations? And even though you may not be capturing the features in there, it's still all traceable back through the variation points and the rules that you put on there. One other thing, and I mentioned this earlier, is about when you start using the tool to help you visualize your designs, to help you make those design decisions. This is then where, if you're starting to say, okay, well, I have a variation over here and a variation over there. Well, let's take a look at that and see what can we make common, because that's where you're going to really save the money is, making things as common as you can, but also realizing where the variation is. So then it helps you to also visualize where that variation is, what is the impact on the design from that variation, and make those cost benefit decisions.
Great. So
yeah.
It sounds like it's the complexity of dealing with this feature model, right? And dealing with it in a SysML, for example, a SysML tool, right? Where SysML isn't really designed for this, that gave rise to some purpose-built tools. And this session is not supposed to be a commercial for products from BigLever, right? But that's one of the things that drove the creation of that product, right? Is seeing that need and saying, okay, we need something different to really efficiently manage and model features and variations and so forth. So
it's
go ahead, Marco or Charlie.
I'll just mention, the feature model, the distinguishing characteristics, it's a separate concern in engineering. And so we, pull it out we know that formal digital modeling, digital engineering, the value of that, the precision of that is a good thing. What we're doing is creating a formal digital model with precise semantics that addresses this specific concern that's different from requirements, it's different from code, it's different from electrical, mechanical, different from SysML v2, needs to be its own thing. And that's really important. Kind of ties back to the theme of the title of this panel, are you missing a piece of the puzzle? And this is a really important piece. It's not well known that if you're really going to do digital engineering, you can't informally manage your options and your variants and your distinguishing characteristics. They just permeate your system, and you can't rely on Bob to always be there to provide the answer for you.
Huge cascading impacts.
What I wanted to add on that is that, so for example, I started my career in MBSC and PLE. So since the first day I started working, I work with the two topics, right? And what I saw is on the MBSC side, MBSC was created to break the silos. No? We say, okay, we have MBSC now, we break the domain silos. But the problem is, if you start to do it within the MBSC, variant management in MBSC and safety analysis in MBSC, you start to do everything in the MBSC too. Then the problem is that you create another silo, that's your MBSC too. And we don't want that, right? So like, I know that's not, so I never tell people to build feature model in Rhapsody. Right? So I say, no, use the right tools to make the feature models. If you want to make small example for learning, okay, do it, but it's not the best way of doing it. And then there is, for me on the MBSC, if you want to talk more about MBSC, since it's so quite popular now, it became quite popular in the last years, is that one of the biggest questions that I get when I work on MBSC is that, especially from the management, yeah, but which is the value? How can I return on my investment, right? So very big, $1 million question for MBSC. Can you prove me the value of MBSC? And then one aspect is that usually when a company starts MBSC, they do it on a specific project. So they try to have a very good level of models, but for one project. So then the company invests a lot of money in that. And then when it comes a second project, if they don't have built the model to be reused, then basically they need to rebuild the model again. No? So it's another effort. So what I want to say is that PLE can boost MBSC as well. So it can be used to increase the model reuse, and not just the model reuse, also the requirements linked to that and the other artifacts, right? And especially now, maybe we will talk later about that, Barclay, SysML v2. SysML v2 finally tackles the variability. So we have variability notation, the concept of variant, concept of variation. And this really, it means that all the elements, all the objects in my SysML v2 will have always a definition and a usage. So are made to be reused, right? So this will for sure boost the product line as well. No? So I see like product line engineering boosting MBSC, and MBSC now, SysML v2, boosting the product line engineering part.
It's a great point. It seems like it's in a way given more prominence, right, to this whole idea of variation management and so forth, that it's a first-class citizen concept, right, in the SysML2
right.
language. And of course, SysML2 is still in its early stages in terms of implementation, right? The standard has been somewhat signed off. We don't see tools yet from vendors, but that's coming, and that'll be interesting to see how those implement variation management and so forth. But we're getting a number of questions here. So let me ask the panel to go a little bit more in depth before we go to kind of the future of PLE, a little bit more in depth on feature engineering and feature models. There's some questions like, how do you select the features? If we haven't thought of things in features before, how do we start into that? And how do we sell people on the benefit of that? Rael had a great question that you see in the chat there, that we've got to sell the benefits of this somehow, right? Because if it's just at a local level, it may not get enough traction in the organization and so forth. So what are your experiences about that, of getting deeper into this feature approach?
I was just out working with a client this week, right? And so what we teach, it's like you've got different systems, right? They're slightly different. if they've never thought of features before, we start to say, well, why is this product different from that one? Why is this system different from that? And they'll give you an answer, and it may not be, it may, well, this one's got this part and that one's got that part. It's like, well, why do they have different parts? And so I always teach people to think like a 2-year-old, keep going, why? And when you get to the end where they just say, that's just the way it is, then that's probably a feature, right? What's the essence of why these things are different? It's like, well, ultimately different capabilities, different performance, different missions, different customer needs at a high level. So people know that their systems are different. They know maybe down at the code level, it's this algorithm versus that one. But the essence of why did we ultimately make that different? That's the feature. You get to the essence. Now you put that in your feature model. So it's a bit of an art form, just like doing MBSE modeling of a system. It's like it's a modeling technique for your distinguishing characteristics across the family, and it's hard and it's easy in a sense. Once you see those features and why did we do this in the first place, it's like obvious. But getting there, people tend to go down many paths before they get to the essence of the why game.
So it sounds like it's not just sort of slapping another layer, of information about the system. It's sort of rethinking from a different paradigm, because if I start to look through these feature glasses, then I see things differently. And in the beginning, it's blurry, as you said, right? And then things start to come into focus, and okay, now I see. Someone else on this subject.
I was going to say, driving commonality is what saves money. Features are what make money. Right. So features exist because they need to exist, because your customers, because your users need it to be different for a legitimate value added reason. And when you figure out what that reason is and you encapsulate it, then that allows you to provide it to other users, other customers. It allows you to market it. It's the thing that is what matters in the end. And if you just say, well, it's different because it's different, then it probably shouldn't be a feature and you should make it common, right? So figuring out that balance is something that is not easy, and it requires people talking to each other. And when we talk about the cost of PLE, it's those discussions that are really the cost of PLE, putting in a governance process, forcing people to talk to each other and say, do I really need it different, or is good enough good enough? And we should use that money that we're going to save on something that really matters, right? And so that's, I think, that the value added part of PLE right there is finding the features, making it something that means something.
And it sounds like that one is not so much an engineering technical distinction, but a business one, right? Like, because somebody's like, well, that's that way because I made it that way, and that's my special little version of this thing, and maybe I don't want to let that go, even if it's better for the whole somehow.
Yeah, absolutely. It's a confluence of business and engineering together, making a decision about what the organization needs and how we're going to do it in a way that doesn't balloon cost.
So where are we going with this? Our last few minutes here, let's touch on kind of the future. In other words, I have a feeling PLE, like everything else in engineering, is in motion, right? We haven't figured everything out. We haven't solved the whole thing, right? So where is it going? We have the advent of SysML2, and I see Andrew here asks, when are we going to see those SysML2 tools? And we've got two tool vendor companies on the panel here, so they can comment on that if they want to. But more importantly, where are we going in PLE? What do we see the trends that people need to be watching out for in coming years?
So if I can, so since you mentioned tool vendors, so by the way, before I was not a tool vendor. Since last year in August, I became a tool vendor. So I'm also in a new role. I was also always on the other side, right? So I was always asking for. Now I have to provide. So we strongly believe in SysML2. So my organization strongly believes in SysML2, and we commit to that, and we are already working on that. So I've been seeing some prototyping, and I'm quite excited, I have to say. So that's why for us, but of course we need to wait. Now there is in the phase. I think next year will be probably released officially, because now is in the phase where we can provide comments, we can test it, so in the beta phase. And so hopefully we already have some prototypes, but to have it really probably within a tool I think we need to wait 2025, so something like that, no? And in general, I would say that the future of product engineering for me is working on configuration management, because configuration management, it's like go together with product line engineering. If you cannot configure, feature is the easy part, let's say. It's not easy, right? But I said before, is a child can understand feature model. No, maybe it was too hard, but I would say that the feature part is not that complicated. The difficulty is to extract the feature, to understand the variation, and so on. But then to manage the assets, there where it's really difficult, not all the different assets, the digital engineering part. And also, what I have now as my tool chain will be different in the future. So it's really important to be open, okay? So with product line engineering, you need to be open. So you need to have a possibility, if you go with a tool vendor, you need to be able to have a tool chain that is open, support open interfaces. So you cannot go with a closed environment, because you cannot have lock-in effect with product engineering. You want to have new assets adding, you want to start with requirement test case. In the future, you want to add the 3D models, but you have not defined yet which will be the tools you are going to use. So that's why it's really important to be open. So I see two key things, of course, on top of SysMLv2 is working on the configuration management aspect. That's very key. And the second one is keep your architecture open, right? So not just, don't try to go with the one solution fits all, and try to choose the openness within your architecture. So that's from a tool vendor perspective, okay?
Yeah, I think, in some ways, product line engineering seems like a new emerging thing, but this has been going on for 20 years in commercial practice at early adopters and small scale. So I'll say a lot of product line engineering, feature-based product line engineering, what's in the ISO standard, that's just commoditized at this point. We know how to do requirements and code and test cases, documents and bombs and all sorts of things. Where I see, innovative things happening with PLE is often combined now with MBSE and digital engineering and simulation. And so, I can point to Bobbi on this one. I think she did some of the early, very innovative work to basically, simulate different variants of a product line to do, trade space studies and trade-off analysis before you, bend any metal and mold any parts and write any code. They're doing full digital model simulation with PLE and variations of features and functions to identify, where to really start on your design activities. So, there's some really nice work. Maybe you can talk about where that's published, Bobbi. I think, again, this is really innovative work that a lot of people in pursuing digital engineering and simulation should really take a look at.
Yeah, so I have published, because I've been working on this for the last several years before I retired. I only just recently retired, so, but I've published papers through INCOSE. Charlie had a symposium, a momentum symposium that I have a video that you can download off of his site. I've done videos for NDIA on this subject. But yeah, he's right. We've looked at, I was working on an effort, we had called it composability. And the whole idea was that you can have a product line of product lines. So your product lines themselves can be hierarchical when you're looking at these systems of, family systems. And the idea was that, if you have, I was working, I'll use the missiles as my example. You have different parts to a missile, and if you can, in an open architecture way, describe the different parts that are common amongst the different types of families of missiles, those parts can be product lines unto themselves, as well as just kind of the higher, more system level of, managing that as a product line. So as you go through your architecture, you can manage each of these levels of your architecture as individual product lines that can come together hierarchical. So you need those features then to be able to help make the decisions And we were finding ways to make this automated, where you can use simulation capabilities, because that's also information that you can put you can associate the features with and put variation points on to feed into simulation environments and have different ways of being able to automatically do different trade studies and be able to select then the appropriate variation of each of the different components that you would need to produce a end product. And so we were working on a lot of different ways to be able to make those decisions. I kind of call it my way of doing a virtual digital twin, because we're all about how we're going to build out these digital twins in our digital engineering environments. But this is a way to kind of virtually, because you've captured that information and you've captured the rules, and you can insert new information with new features as you go along, and then use your simulation environments to help you make those decisions and identify what are the appropriate features, what are the appropriate components that you need to build out a system.
Very good. So let's see, I've got one other thing to throw at Charlie based on some of the questions here. So, BigLever software obviously is one of the key players in this. How is SysML2 changing what you have? How are you adapting this? Is it going to make things easier somehow because of variation points, or what are you having to do to deal with that? Or have you fully figured that out yet?
Yeah. Well, I'll have to admit, after the ISO standard, I was the lead editor on that. I talked to Sandy and Ed on SysML v2, and they said, why don't you come over here and make sure SysML v2 is compliant with ISO? So I was the one that led the working group on the variation management portion of SysML v2. So I'm fully adapted to what that is. And we sort of created it to make sure it matches this notion of feature-based product line engineering and will be compatible with PLE tools in the industry, so that SysML v2 tool vendors and PLE, feature-based PLE tool vendors, it's just going to plug in and work out of the box. So,
all right.
And
sounds like it is going to make it somewhat easier. Go ahead, Marco.
It applies also for as Charlie said, for the PLE tools, right? So that's why so Charlie, I think, did a good job to secure that and to.
Very nice.
Yeah, so.
Well, let's see, we're just right at time here. So let me wrap up with just a couple of notes. Some people have asked some questions that we maybe didn't quite get to or only touched on a little bit. So what we're going to do is ask panelists to comment on some of those questions later. We're going to publish the result. Some people have said, where do we get these papers and presentations and things that Bobbi and others have mentioned, right? So we will collect that information, and we'll also publish that on the Calling All Systems webpage. So that's where you can find all this. Give us a little bit of time, to collect this stuff and put it up there. But INCOSE.org/callingallsystems, right? That's where you'll find that. And then also the PLE working group is happy to have you, right? So any of you that are INCOSE members, we would love to have you join the PLE working group. And you can do this by going into your user profile in INCOSE.org, where you log in and you go down and you say, join a working group, and you just select it. And there you are on the list to participate with that. So Rowland and Marco and others would love to have you in that as well.
And Barclay, we are with the PLE working group chair. We will be in Hawaii in the IS Symposium.
Oh yeah.
So that's why if you come to Hawaii, please just search for me. I will be there presenting some paper as well. So that's why, also my colleague Charlie, I guess, will be there. Probably Randy. I don't know if Randy will be there, but you, Rowland. So we are there. Just search for us and we will help you.
Perfect. All right, we'll leave it right there and on time. Thank you, everybody, for attending. Thanks to our panelists and to our sponsors, BigLever Software, for this session, and Dassault Systems for the whole series of Calling All Systems. And watch for the next Calling All Systems coming somewhere down the road on another subject, and we'll see you there.
All right. Thanks so much, Barclay.
Thanks so much.
Thank you very much. Bye-bye.